In this video, we're going to multiply fractions. I have at the top of the screen here the basic ideas of multiplying fractions together. Number one is you do not need an LCD, lowest common denominator. If you're not sure what that is, doesn't matter. We don't need it right now. We'll get to that in another video. You can cross-reduce, and I'll show you what that means in a minute. The biggest thing to remember when you multiply, you're going to multiply numerator times numerator, which means, for example, in this thing, I'm simply going to multiply 5 times 3, and I'm going to get 15. Then I'm going to multiply 6 times 10 and get 60. The thing you always have to remember is that you have to reduce your answer. No matter whether you're multiplying, adding, subtracting, dividing, you always need to reduce your answer. So I'm going to look at this real quick and I'm going to say, well, what numbers will go into 15 and 60? I know 5 will. So 5 will go into 15 3 times. And 5 will go into 60 12 times. And look, I still have things that can go in here. So 3 will go into both. 3 will go into 3 times, or excuse me, 1 time. And 3 will go into 12 4 times. So my final answer is 1/4. Now, what I want to bring your attention to is this idea that you can cross-reduce. In this problem, it was relatively simple. I just multiplied across and I can reduce. However, when the numbers get larger like this, it's really handy to have a tool ahead of us that allows us to multiply much simpler numbers. So I'm going to write these two numbers again. And if you're not familiar with it, that dot in the center means multiplication. A lot of mathematicians kind of steer clear of writing that X that we used to see in elementary school because, frankly, it looks like an X and it gets mixed up with algebra later in the day, later in the material. So we're going to look at the idea of cross-reducing. So cross-reducing means I can reduce any fraction if and only if there's multiplication between it, whether it's top and bottom here or top and bottom here. So you have 4 sets of pairs. I can see if there's any common factor between these two, between these two, between these two, or between these two. So when I'm looking at this fraction, there's really nothing in common between 5 and 6. But between 5 and 10, there most certainly is a common factor. 5 will go into both. So 5 goes in here once, and 5 goes in here 2 times. So if you see now, in order to multiply across, I have a lot smaller numbers already. This is really handy. So then I'm looking for other things. I'm looking here that 3 and 6 also have a common factor of 3. 3 goes in here once, 3 goes in here twice. So now when I'm at that step 3, multiplying across, I'm multiplying much simpler numbers. Now granted, 5 times 3 in my original wasn't that complicated. But we're looking here, and I really do this. I circle my numbers to remind myself what number I'm actually dealing with. But 1 times the 1 up top is 1. And the 2, that's the number that's left in this part of the fraction, and this 2 over here, 2 times 2 would give me 4. So if you look, it gives me the same answer, but I reduced ahead of time rather than reducing at the end. Some of you might see this and go, that's a little complicated. I'm just going to always multiply across. Well, I want to look at this number here. If I multiply across here, I'm going to do it the first method. So 4 times 10 is 40, times 14 is 560. Then 7 times 11 is 77, times 15 is going to be 1,155. And this is the correct answer, but again, I have to reduce it. And you can see these are pretty large numbers. So what I'm going to do instead is I'm going to, again, do that idea of reducing. And again, they're in parentheses. There's no operation between it, so there's multiplying all through here. So I'm going to look at different pairs. And again, they can be all the way over here as long as one is in the denominator and one is in the numerator. For example, I see that 14 and 10, they're side by side. I can divide those both by 2, but you cannot reduce side by side. It has to be one up and one down. So again, I'm going back to the 7 and 14. 7 goes in here once, 7 goes in here twice. Again, if I'm looking at this, this 2 is what's available now. I couldn't reduce the 14 anymore because I have already. So this is now a 2 up top. So I'm going to look for other pairs. See if you can find another pair that has a common factor. Again, one up and one down. And I see that 10 and 15 can both be divided by 5. So 5 goes in here twice, and then 5 goes in here 3 times. So again, we're in a lot better shape already. So instead of multiplying that 4 times 10 and 14 when I got that huge 560, now I'm simply multiplying this 4 that's left times 2 times 2, and that's going to give me 8. 4 times, I'm sorry, it's going to give me 16. I added those. Shame on me. Then I'm going to multiply 1 times 11 times 3, which is 33. And again, 16, I'm going to rewrite that because that kind of looks a little nuts. 16 over 33 is as reduced as it can get. So that is, again, it takes a little bit to learn how to cross reduce, but it's definitely more simple than trying to reduce those huge numbers just like that. For the rest of the multiplication problems, I'm going to continue to cross reduce before I multiply in order to make the problems a lot easier. So I have two more examples here. One of them is here, where I'm multiplying a number by a whole number. This is not the same as simply writing it 8 and 9/10. This is multiplying the fraction 9/10 by 8. So we're going to do something slightly different. When I have a whole number, any whole number can be made into a fraction by writing it over 1. So before I even do the multiplication, I have to set it up in a way that I can understand. So now that I've got the whole number written in the correct form, then I can do what we've done before, which again is cross reduce, as I call it, or looking for a factor that's in common both top and bottom. 8 and 10 both have a common factor of 2, so 2 goes in here 4 times, while 2 goes in here 5 times. So then I can multiply across. 4 times 9 is 36, while 1 times 5 is 5. Now if I'm looking over at this one, I cannot do any work until this has been turned into an improper fraction. I'm going to go through this quickly. If you need to remind yourself on how to turn a mixed number into an improper fraction a little more, there's another video here on my channel. So in order to do this, we're going to multiply always denominator times the whole number, which is 25, and then we're going to add the top. So 5 times 5 is 25, plus 3 more is 28. It always goes over the same denominator. Then over here, I'm going to do the same thing. 3 times 7 is 21, plus 4 more is 25. And now I'm ready to go. So when I'm going to multiply, again, I'm looking to cross reduce. So here, 7 is a common factor between these two. So 7 goes here and here once. 7 goes in here 4 times. Between these two, I have a 5 and a 25. 5 goes in here once. 5 goes in here 5 times. So when I multiply through, I get 5 times 4 is 20, and 1 times 1 is 1. You can write it like that, or 20 over 1 is simply the whole number 20.